Hello student, today we are going to learn a very important topic named as optical fiber. So let's see, the topic is optical fibers. So first start with the meaning of optical fibers. Optical fibers. So please pay attention here. Optical fibers are the cables which help to send data from one place to another place with very high speed without much loss of data. What is optical fiber? Optical fibers are the cables which help to send data from one place to another place with a very high speed, because the data can be sent in the form of light, and we know very well that the speed of light is having value speed of light. Speed of light is having value 3 into 10 raised to 8 meter per second. Speed of light generally denoted by the symbol, which is symbol C, and it having value 3 into 10 raised to 8 meter per second. So, listen again, I repeat, optical fibers are the cables. These are the cables which help to send data. That data should be in the form of light, from one place to another place. From one place to another place with very high speed, because that speed should be the speed of light. That speed is having value 3 into 10 raised to 8 meter per second with very high speed or fast speed without much loss of data or much loss of energy. Same thing, much loss of data. Clear? So listen, optical fibers is a very newly renewing branch, and it having a very specific important meaning. Optical fibers are generally the cables, or we can say that if there were no optical fibers, there were no internet. Internet is due to only the optical fibers cables, and thus it is very important in this modern technology. So let's see its meaning. Optical fibers are the cables which help to send data. That data should be in the form of light with very high speed, because the speed of light is having value 3 into 10 raised to 8 meter per second. So that optical fiber transfer that form of energy or that data in the form of light from one place to another place at very high speed, with very high speed, fast speed, and without much loss of data. Such cables are known as optical fibers, which is also called as fiber optics. Got it? Now let's see the structure or nature of optic fiber. This is about the meaning of optic fiber, definition of optic fiber. Now let's see the nature of optic fiber, or we can say that structure of optic fiber. Let's start. Structure of optic fiber. Structure of optic fibers. Generally, optic fibers are the cables which are basically made from transparent material. That means it is clear that they are generally made from either glass or either transparent plastic. So optic fibers are generally made from transparent material, but it has some specific structure, and that structure include that optic fiber having the central part known as core made from one transparent material. Again, that core is surrounded by another transparent material named as cladding. Core is surrounded by another transparent material called as cladding. And the important condition is that refractive index of core must be greater than refractive index of cladding. So let's see first the figure for optical fiber cables. So structure of optical fiber cable in that figure. In case of structure of optic fiber, as we know that the optic fibers are generally made from transparent materials. That means they are basically made from either glass or plastic, and it consists of a central part. That optic fiber consists of central part named as core. The central part named as core, which is made from one transparent material, and that core is surrounded by another transparent material called as cladding. This dotted line represent the axis of optic axis. That means middle axis for that core. Now this portion, outer portion, which is called as cladding. Outer portion is called as cladding, and this middle part is called as core. So this one is called as core. Core having refractive index of core denoted by the symbol N1. It is always denoted by the symbol N1, and this core is again surrounded by cladding, another transparent material named as cladding. Cladding having refractive index Ri denoted by the symbol N2. Similarly, this one portion is also for cladding. This one is also for cladding. Cladding is having refractive index denoted by the symbol always N2. And the main condition for this optic fiber cables are, the main condition is refractive index of core, that is denoted by the symbol, which symbol? N1, should be or must be greater than refractive index of cladding. Refractive index of core denoted by the symbol N1 must be greater than refractive index of cladding. Then the light rays which is coming into the, listen carefully, suppose this one is the axis, entrance point for that core. Now the light ray is coming into the core. That light ray coming into the core suffers multiple total internal reflection. It suffers multiple total internal reflection, and hence it can travel a very long distance without much loss of data. The light ray coming into the core, this middle portion is called as core. It is made from one of the transparent material, each having refractive index denoted by the symbol N1. Again, that core is surrounded by one another transparent material known as cladding, and cladding having refractive index N2. Important condition for this propagation of light through that optical fiber is refractive index of core, which is denoted by N1, must be greater than refractive index of cladding, denoted by the symbol N2. And now the light ray which enters into the core, it suffers multiple total internal reflection, and in this way that data or that energy, that signal can propagate, can travel from one point to another point with a very high speed in the form of light without much loss of data. This is about the structure of optical fibers. Got it? Okay. Now let's see the another topic, next topic. That topic is propagation mechanism in optic fiber. That topic is propagation mechanism. Propagation mechanism in optic fiber. So, optic fiber works on the principle of TIR, that means total internal reflection. Listen again, this one is important topic, and always remember that optic fiber works on the principle of, which principle? It works on the principle of TIR, total internal reflection. And total internal reflection is the phenomenon in which light confined into the denser medium. Denser medium means that medium which having the greater refractive index. Here we know very well that refractive index of core is greater than the refractive index of cladding. So we can easily call this core as a denser medium. This one is denser medium because its refractive index is greater than the cladding, and this one is called as rarer medium. So listen again the definition for TIR. TIR stand for what? Total internal reflection. TIR stand for total internal reflection. Total internal reflection. Let's see its definition. Total internal reflection is the phenomenon in which the light ray is confined into the core. It is, we can say that confined means what? It is enclosed into the core while traveling for dense. Dear student, as I told you, this optical fiber cables works on the principle of TIR. TIR means what? TIR means total internal reflection. So let's see the meaning of TIR, total internal reflection. Total internal reflection is the phenomenon in which the light ray which is enters into the core. Core is the denser medium. The light ray confined or enclosed within the core while traveling from denser medium into the rarer medium. But the condition is that when the angle of incidence is greater than critical angle. This phenomenon is called as total internal reflection. Listen again. Optical fiber works on the principle of total internal reflection. And total internal reflection is the phenomenon in which light ray confined into the denser medium while traveling from denser medium into the rarer medium when the angle of incidence is greater than critical angle. Such a phenomenon is known as total internal reflection. Now, let's see the meaning of critical angle. New word is introduced in this definition for total internal reflection, and that word is, that term is critical angle. So, let's see the meaning of critical angle. critical angle denoted by the symbol theta c. Critical angle is denoted by the symbol theta c, where c is a suffix used for critical. So let's see the meaning of critical angle. Critical angle is that angle of incidence for which angle of refraction is 90 degree. Critical angle is that angle of incidence. That angle is called as critical angle, for which angle of refraction is 90 degree. Such angle is called as critical angle, and it can be obtained with the help of Snell's law. So let's we define, or we can obtain that formula for critical angle by using Snell's law. Snell's law. Snell's law is that I sin n1 is equal to r into sin n2. Snell's law is having equation I into sin n1 is equal to r into sin n2, where I is angle of incidence of the medium having refractive index n1 and r is angle of refraction of the medium having refractive index n2. But here in this case I is having value what? I is equal to theta c and r is equal to 90. Now put above values. Put these above values in Snell's law equation. In Snell's law equation. So we get what we get. Instead of this I, we have to put there theta c. So this Snell's law, this equation is called as Snell's law equation. So instead of I, we have to put here theta c. It becomes theta c into sine of n1 is equal to r. Here right hand side is r into sine of n2, but here r is having value 90 degree. 90 into sine of n2. Theta c into sine n1 is equal to 90 into sine of n2. So